Hello, everyone. Our next question, which is question number 5. This question is about calculating area of this irregular shape. So all relevant measurements are given in these two tables. For example, here we are given the value of AB, BC, and AC lengths. For example, here is AB. We have a BC here, and CA is this side of our this regular triangle. And then above over here, you can see that there are a few structures, and among these structures, there are mainly two types of structures. Number one, right angle triangles on the sides, and in between, there are 6 trapezium. So we actually can calculate area of these all structures individually. So okay, so for this structure, what we should do, we should divide it in different parts. Let's divide that this main regular triangle is our triangle number 1. And then on this left side, the first structure, which is a right angle triangle, this is our structure number 2. Then the next one, it is trapezium number 3, 4, 5, 6, 7, 8, and this is the 9, which is also a right angle triangle. Okay, so now these all structures, you can see that we can divide them in 3 different types of structures. Number 1, right angle triangles, that is triangle number 2 and number 9. And second is the non-right angle triangle, which is triangle number 1. And for this, we will use this given formula to calculate its area. What for triangle number 2 and 9, both of them, these are right angle triangles, and we know that area of a right angle triangle is given by 1/2 times base times height. Now, let's understand the data which is given in this table number 2. Here, what is given, that these are the values of coordinates in the second column. In the third column, these are values of heights of these sides. So from these coordinates given in column number 2, we will calculate the lengths of these bases. For example, for triangle number 2, we can calculate the area by like this, that 1/2. Here base is that point number 2, which is, sorry, point number 1, which is 65.5, then minus point A, and its coordinate is 0. So this is the total length of the base of our right angle triangle, and we times it with the height, and the height of the point 1, which is over here, is given over here, which is 46.235. 46.235. So our total area, if we calculate this, so you can use a calculator to calculate this area. Answer is 1514.1963 meter squares. Never forget to give units. Now, in the same way, we can calculate area of our triangle number 9. So I will call it area number 2. And now the area number 9, this is equal to 1/2 Now, the base. How we will calculate the base? The coordinate of C minus coordinate of point 7. So for the C, the value of the coordinates is 5, 2, 4 minus 4, 5, 8.5, and then times this height at a point 7. This is 10.178, and this area is equal to 333.3295 up to 4 decimal points. Now, these are our areas. Now, we actually can go to the other structures that are trapezium. For example, area number 3, how we will calculate the area of trapezium. This area 3 is the area of trapezium, and it's actually the formula is our A plus B divided by 2 times H. So let me explain you that what these actually means. Here, A means the height of the side 1, and B means the height of side 2. Then H is the distance between these two sides that are two parallel sides. So A and B are the heights of parallel sides of a trapezium, and H is the distance between that two parallel sides. Okay, now if I actually use the given values for A and B, you can see that A is the height at a point at a point 1, and B, we can consider that it is height at a point 2. Like in this table, that this height and this height we will use as a AB for our trapezium number 3. Then the distance from a point 2 to 1, that will be 131 minus 65.5. So in this way, we can calculate it in this way that, for example, our A is 46.235 plus 38.986 and divided by 2. Now we need to multiply by the H. That value is 131 minus 65.5. So this answer A3, you can put these values in your calculator. The answer is 2790.9878 meter square. Using the same formula, we can calculate our area 4, 5, 6, 7, and 8. And for that, we will use the values given in this table. And in the same way, you can see we can calculate the area 4. This area 4 will be that you can see that in area number 4 that we need to use the height at a point 3 and at a point 2. Then divide it by 2, meaning the average height of point 2 and point 3, and times it with the distance between 3 and 2, meaning that we are going to calculate it 195.5 minus 131. So that will be our area 4. Let's calculate this as well. This is going to be 38.986 986 plus 8.056. Then we are these are two heights divided by 2, then times the distance between these two parallel lines, 196.5 minus 131. So our calculator gives its value 1540.6255 meter square. Good. So in the same way, you are going to calculate your other areas, area 5, area 6, area 7, and area 8. Okay, so I'm going to give directly the values of these areas, because we know how we can calculate these areas. So area 5 is 951.7805 meter square, and area 6 is 2264.7280 meter square. That if, for example, you have this question in exam, you need to actually do a proper workout. Then you will actually get a maximum marks instead of directly giving areas. So then area number 7 is 2863.3325 meter square, and area number 8 is 1619.8805 meter square. Good. So we have calculated all areas of these shapes that are at the top of the main regular triangle. For the regular triangle, which is our area number 1, we will use this given formula. For that, first of all, we need to calculate S. So this S is simply is equal to A plus B plus C divided by 2, meaning that it is actually the addition of all sides of this triangle that are given in this table. For example, this is A, this is B, this is C. So our answer will be 252 plus 398 plus 524 divided by 2. So this is the value of S, that is 587. This is the value of S. Now this is actually very easy for us to calculate the area. So area, I will call it area number 1. So we can just write over here what, when you are solving this question, you actually can go in a sequence with the flow of all these areas. So area 1 will be the square root of S into S minus A times S minus B into S minus C, and that is going to be 587 square root, then times 587 minus 252, which is the value of A, then times 587, take away 398, then times 587, which is value of S, take away 524. So these all factors are under the square root, which is area 1. You can put these values in your calculator and you can get the value of your area 1, which is 48,388 0.5525 meter square. Okay. Now, our all areas have been calculated. We actually need to calculate the total area of this structure. For that, you can say the total area A is equal to A1 plus A2 plus A3 plus A4 plus A5 plus A6 plus A7 plus A8. So you will actually calculate these all, you can sum up these all areas that we just calculated. It will be your final answer. So in this way, you need to solve this question. So once again, I give you a very short briefing once again that how you can solve this question. Our question is to calculate the total area of this structure, and this structure is not a regular structure. What we can make it, we can divide it in a different small regular structures. For example, this structure number 1, which is our triangle, and then this structure 2 is actually, you can see it is a right angle triangle. Then the structure 3 to 8 are trapezia, and then the structure number 9 is again a right angle triangle. So the values of the sides of this regular triangle number 1 are given in table number 1, which are the sides A, B, C. So you can actually can see that that what I wrote here, you can say that AB is A and BC is C and AC is C. So it's actually, sorry, this is B. So now we can actually calculate the area of this regular structure using this given formula that we actually did the calculations here to calculate area number 1. For area number 2 and 9, we will use the formula for the area of a right angle triangle, which is half times base times height. So that will be very simple. You can calculate one by one. What we actually need to know the height. What the height of this right angle triangle number 2 is given over here, 46.235 meters. And then what will be the value of this base? That is the distance from a point 1 to point A. So point A is at 0 and point 1 is at 65.5. So the distance from 1 to A is 65.5. Okay. In the same way, you can calculate the area of right angle triangle number 9. What here, the height is given, then the length of the base, that is from point C to point 7. So point C is at 524. Point 7 is at 458.5. So you just take away the 458.5 from 524. That will be the length of the base from C to 7. So this value you can use to calculate the area of this right angle triangle number 9. Now the structure 3 trapezium, 4, 5, 6, 7, and 8 as well. So we can use the formula to calculate the area of the trapezium. That is the height of these parallel lines, meaning you are going to calculate the average height of these two parallel sides. So meaning that you are going to add the height at a point 1 to the height at a point 2, then divide it by 2. That will be the average height times the distance between point 2 and 1 that you can calculate from point 2 value, take away the point 1 value. So in this way, you can calculate your area of trapezium 3, 4, 5, 6, 7, 8 as well. So after calculating these areas, add these all calculated areas. That will be your total area of this irregular structure. I hope you understand that how you can solve this question. It is a very easy question. Use your calculator for calculations, but carefully when you are putting the numbers, because you need to do the calculations up to the 3 decimal points. I did here 4 decimal points, but you can actually do it up to 3 decimal points. That will also be fine. Thank you very much. Hope you understand this question.